chemistry is unique in that chemistry builds on itself. So the first thing I have to do to you or for you is I need to build the foundation that you will need in order to, as we advance in the chemical topics, in order for you to understand those topics, you're going to need to be pretty good at this foundation. So, this first section is really not chemistry, it's more like middle school science. Nevertheless, I need to know that you have this down pat in order for you to succeed when we get into chemistry that's a little more difficult. So the first thing I need to teach you is I need you to be able to identify the basic quantities that we will use most in chemistry and to be able to identify its SI unit. Okay, so some properties can be observed by the unaided eyes. You can see whether something is white or the box is square. It's a square box. Those things you can observe. The person is tall. Okay, but other things have to be measured. In order to know how tall that person is, you're going to have to take out an instrument and you're going to have to measure it. All right. A long time ago, every country had its own way of measuring things. And they realized that if they're going to have to trade with other countries, they're going to have to standardize what they mean by a foot or by a pound. Everyone that you are trading with has to agree how much is a pound, or else people get cheated. And when people get cheated, they get really angry, and that's how wars get started. So scientists use the Système International, the SI system, or what we here in America call the metric system, in order to report these measurements all over the world. It does not matter if you measure a person's height using meters. It is not going to matter where you send that information to around the world. They're going to understand it. So when and where was the metric system first introduced? It was introduced in France in the 1700s. That is why it's called the Système International. That means the international system. The international system, or SI in French, Système International. That is what we call the standard set of units used all around the world. So why do scientists all over the world use the SI system? It's just better. It's just better. I mean, for example, volume. I believe, and sometimes I get this mixed up, I believe that there are 16 ounces in a pint and that there are 2 pints in a quart, though sometimes I think there might be 4 pints in a quart. No, I think there's no. I think there are 2 pints in a quart. And then there's 4 quarts in a gallon. Because I know that if the pints is 2, then the quarts has to be 4. That is just too hard to understand. I have to remember 16, and one of them is 4, and the other one is 2. That's too much. Metric system is better because everything is 10 apart. See, we use quarts to describe things that are more than pint size. So it would be really nice if there were like 10 pints in a quart, and then there would be 10 quarts in a gallon. Something like that would be a whole lot better. And that's the way it is with the metric system. People all over the world use it regardless of language. Okay, a meter is the same length here in America as it is in China. What are the 7 basic units? Number 1, the gram. That is the unit that we will use to describe mass. Degrees Celsius is the unit that we will use to describe temperature. Second is the unit that we will use to describe time. Meter is the unit that we will use to describe length. Mole is, that's a funny sounding word, I know. But mole is the unit that we use to describe an amount of something. Pascal is named after a brilliant scientist. His name was Blaise Pascal, and that is the unit that we use to describe pressure. Joule is named after James Joule, and he worked with heat energy, and that is the unit that we will use to describe heat energy. So, why isn't volume one of them? Why didn't we put liters there? Because volume is derived from the units of the seven. What does it mean to derive? That means you had to multiply or divide those seven in order to come up with volume. How do we derive volume? Well, volume is length times width times height. Imagine a cube, and a cube's volume is its length, width, and height. Length, width times height. Okay, that's volume. That's volume. Okay, width is just another word for length, and height is really just another word for length. So really, volume is length times length times length. This is, if this was a cube and it was 1 centimeter by 1 centimeter by 1 centimeter, you could actually drip a whole milliliter of water into this cube and it would fill it up. So what happens if we need to measure, what we need to measure is much smaller than our base units, like the meter. For example, the base unit is the meter. Okay? So the meter is roughly about 2/3 of a yard, or maybe close to a yard. Let's say close to a yard. Okay. What if I needed to measure the size of the COVID virus? Okay. Meter measures length, and I would need meter, but a meter is too big. So what we do is we come up with prefixes in order to scale it down or to scale it up. What if we wanted to measure the distance from the sun to our nearest neighbor, which is Alpha Centauri? Would we use a meter? No. We would use a kilometer. Kilometer is a much bigger length than a meter. So we use prefixes to indicate fractions or multiples of the SI unit. So what are the most important prefixes and what do they mean? Okay, kilo. So if you have a kilo in front of meter, that means you have 1,000 meters. Kilometer, 1,000 meters. So a meter, 1,000 meters is equal to 1 kilometer. Kilometer is 1,000 times bigger than a meter. A decimeter is 1/10 of a meter. 1/10. We're going to use decimeters a lot. 1/10. So there are 10 decimeters in a meter. A centimeter is 1/100th of a meter. So there are 100 centimeters in a meter. A millimeter is 1,000th of a meter. So there are 1,000 millimeters in a meter. Okay? So what are some examples of this? Well, a common door is going to be about 2 meters. 2 meters. The thickness of a paperclip wire is 1 millimeter. 1 millimeter. A 1 cubic box, that's a box that's 1 meter long, 1 meter wide, and 1 meter high, could possibly hold a large dog comfortably. But a cubic meter is too big. We're not going to be dealing with things that big. So what are the units used for volume? And what are the relationships to each other? Volume is defined, once again, as length, width, and height of an object. So the common units are cubic meter, which is too big, cubic decimeters, and cubic centimeters are what we're going to use. And cubic decimeter, that's SI, but you probably are more familiar with the metric version of it. That's a liter. So a 2-liter bottle is going to have 2 cubic decimeters in it. And a cubic centimeter is a milliliter. Same thing. Same thing. Okay, if you like to watch medical shows, you're probably familiar with the term cc. Give them 200 cc's of ivermectin, whatever that is, and that means 200 milliliters. So cubic centimeters. Doctors use the abbreviation instead of cm3. They use the abbreviation cc. cc. What are the most common units used for volume? I think I already went over this. Yes, a cubic decimeter is equal to a liter. A cubic centimeter is equal to a milliliter. So 1 cubic decimeter is equal to 1 liter, which is 1,000 cubic centimeters, 1,000. So you need to remember that. But your teacher will also give you a periodic table that on the back of the periodic table you will find these at about, if you were to treat it like a clock, at about 1 o'clock you would see this relationship. It's a very important relationship. About 1 o'clock on your back of your periodic table. What are the different quantities we will be measuring in chemistry, and what unit will we use? Here we go. Mass, grams. Symbol, G. Volume, milliliters or cubic centimeters, same thing. Liters or cubic decimeters, same thing. Temperature is going to be Celsius, that's in metric. Kelvin is in SI. The amount is going to be mole. Make sure you're writing this down. Energy is in joule, and pressure is in atmospheres, or I told you about them, pascals, kilopascals. And the reason why we use kilopascals is because a pascal is too small. Time is in seconds, S.